Okay, guys, good morning. So let's continue where we left off. This is where we were, right? We were talking about these two guys, Eric and Mike. Eric deposits 100 into a savings account at time 0. It pays interest at a nominal rate of I, compounded semi-annually. So for now, I'm calling it I2 because it's compounded 2 times a year. It's convertible 2 times a year. Mike deposits 200 into a different savings account at time 0. So we're here, which pays simple interest at an annual rate of I. Eric and Mike earned the same amount of interest during the last 6 months of the 8th year. Calculate I. So last time before we had to leave, we were trying to establish how much interest each one has earned on their account, right? So one way to do this problem is to take A of 8 minus A of 7, because that's the amount of interest, times 100, of course, because you're starting with 100. This guy is earning, Eric is earning compound interest. So what I've done is 100A of 8 will give me the amount at time 8. 100A of 7.5 will give me the amount at time 7.5, and I will take the difference. That will give me the amount of interest earned between 7.5 and 8. Do you understand that? So because we are dealing with 1 plus I2 over 2, where I2 is the 6-month rate, we are establishing that in 8 years, there would have been 16 6-month periods. That's why this is 16, right? So let's say, I would like to write that here. Let's write it in some other color. This is 16 periods. And this one is 15 periods. This one. And that's why these are what they are. Do you understand this clearly? So I'm saying that that's one way to do it. Or the other way to do it is to just take the accumulated value at 7.5 and apply the interest rate to it. So this is the accumulated value at 7.5. It's just 100, 1 plus the 6-month rate raised to the 15th power. That's how much money I have at this time, 7.5. And then let's multiply that by the interest rate, which is I2 over 2. Is that totally clear or no? Okay, so we'll deal with Eric in a minute. We'll come back and set his interest equal to Mike's interest. Let's talk about Mike for a moment. So Mike started with $200 at time 0, and we want to know how much interest he's earned between here and here. So this is just 200 A of 8 minus A of 7.5, and this is simple interest. So how much is A of 8 for simple interest? Can I elaborate on this? This would be 200 times, what's A of 8 for simple interest? 1 plus I8 minus 1 plus I7.5. That's one way to do it. The other way to do it is to say that he is making an interest rate, he is earning an interest rate of I for 1 year, the same I on his original capital, because this is simple interest. So for half a year, he will earn half of I. Right? Finished. So how about, instead of all this, I could have cut to the chase, so I'm going to say here, or 200 times I, but times T over 2. So 1 over 2. Half a year, he's going to make half as much interest. Right? The formula is that for the number of years, the formula is just IT times the original principal. So this is 200 times I times T. Half as much interest. That should better give me the same answer as that one. And of course, I'll check it and I'll set them equal in a minute. Do you understand? Any questions with that? Okay, so let's set these equal and finish it up. So 100 times 1 plus, now I2 is being called I, they said, right? Eric's I2 is being called I. So this is 1 plus I over 2 to the 15 times, I'm taking this from here, 1 plus I over 2 to the 15th times I over 2 equals 200 times I times 1 over 2. So this and this cancel, and it's just 100I. So set 100I equal to 1 plus I over 2 to the 15th times I over 2. And solve this equation. Can you solve this right now? Would you solve this right now? I have 100 on the left side, I have 100 on the right side, let those cancel. I have an I on the left side, I on the right side, let those cancel. So this and this will cancel, and this will cancel. So now I have 1 plus I over 2 to the 15 equals 2. One plus I over 2 equals 2 to the 1 over 15 power. I over 2 equals 2 raised to the 1 over 15 minus 1. Therefore, I equals 2 to the 1 over 15 minus 1 times 2. When I do this, what do I get? Two raised to 1 divided by 15 minus 1 times 2. 0.0945. 88. That is the value for I. Are there any questions? Yes, sir. I2 is the nominal rate convertible twice a year. So I2 is the nominal interest rate convertible twice per year. So this superscript tells you how many times a year interest is convertible. How many times per year interest is convertible? Right? Let's do another question. I'll make it up. Example. I4 is equal to 6%. Start at time 0 with $200. How much do you have at t equals 1.5 years? You want to try for a moment? Finished? Okay, so what is the quarterly interest rate? How much? No, this is the nominal rate convertible quarterly. Let's elaborate, okay? This is the nominal interest rate convertible quarterly. So this implies that the quarterly rate for 1 quarter is this divided by 4. Okay? So the quarterly rate, you can call that I 1 quarter, like that, is I 4 over 4. That is the meaning of this, okay? So this would be 0.06 divided by 4, which is 0.015. I'm starting with $200 at time 0. Here's time 1, and here's time 1.5 years. How many quarters in 1.5 years? 6 quarters. 6 quarters. So this is my first quarter, second quarter, third quarter, fourth quarter, like this. So I'm saying that this 0.015 is compound interest every quarter. So every time this is 1.015, another 1.015, and these will be multiplied. You follow what's going on? So my answer would be $200 times 1.015 raised to what power? 6. That's what this means. Are you with me? What's your question? Yes, sir. When nothing is mentioned, the assumption is compound interest. If it was simple, they would specify. Any other question? Let's go to the next page. Oh, by the way, before I go on, should I have shown, taken a moment to show that this and this is equivalent? And that this and this is equivalent? Let's just show that, okay? Just so that everything is complete. So let's talk about Eric here for a moment. Want to show that there's a 100 and a 100 here, so I don't have to get involved with that. I want to show that 1 plus I2 over 2 to the 16 minus 1 plus I2 over 2 to the 15 is in fact equal to this mess right here, right? So let us, I have 100 sitting here. Let's leave that 100 just sitting there. So factor out the 1 plus I2 over 2 to the 15th power. And that leaves me with 1 plus I2 over 2 minus 1. So the plus 1 and the minus 1 will cancel. And you do, in fact, end up with exactly that. So this is 100, 1 plus I2 over 2 to the 15th times I2 over 2, which is what we had assumed here. So that makes sense for Eric. And for Mike, I want to show that 200 times 1 plus 8i minus 1 minus 7.5i. So 1 and minus 1 cancel, and I in fact have 8i minus 7.5i, so that's just a half an I. So 200 times 1/2 times I, which is exactly what we assumed here. So it's all good. Whether you look at it as A of 8 minus A of 7.5, or you just look at it as a half a year's simple interest, of course you're going to get exactly the same statement here. Everybody okay with this? Okay, now let's go to the next page, page 14.
So for the example we just did, can we use the formula I equal 1 plus I to the n over n?
Yeah, that is in fact what I used. See? Right here. So I used 200 times 1 plus I 4 over 4 to the 6th power. So 1.5 times 4, which is 6. Let me make sure that you can see this. That is in fact what I used. So 1 plus I m over m to the 4 times 1.5 years. Get it? Okay.
Can you put that last part, not the other page?
Eric?
Yes. For 1%. Okay, I'm good. Thank you.
You're welcome. So I'm on page 14. Annual percentage yield. Otherwise known as APY, is the annual effective yield rate governing an investment, which will satisfy the time tau equation of value, which we will be discussing at a point later in time. We'll get back to that, in other words. If a bank offers nominal interest IM, they will also provide the APY, which is the annualized rate I. In other words, we know how to convert IM to I, right? What is the formula? The formula is 1 plus I equals 1 plus IM over M to the mth power. Because we know that at time 1, 1 plus I is what you will have if I is the annual rate. And we know that 1 plus the nominal rate divided by the number of times it's being converted raised to the mth power, just like I had here. 1 plus 0.015 raised to the 6th power. I'm doing the same thing here. So this would be 1 plus the nominal rate divided by m. That will give me the rate for 1/mth of the year raised to m power, because there are m such periods. Follow? So the formula for I is just solving this, which is 1 plus I to the m over m to the m minus 1. I brought the 1 to the other side. That's all I've done. They do this because our accumulation functions and present value calculations deal with an effective interest rate, I. This is the effective interest rate, I, right here. Example, the bank offers 12% nominal interest compounded quarterly. What is the APY? Can you do it? I want I. Go solve for I. So I have 1 plus I equals 1 plus IM over m to the mth power. Again, I4 equals 12. So I4 over 4 equals 3%. So 1 plus I equals 1.03 raised to the 4th power. I equals 1.03 to the 4 minus 1. .1255. So notice that I4 was 12 and I is slightly more, 0.1255. So I4 is less than I as expected, right? You can get away with a lower interest rate because you are compounding more times in the same 1 year period. So I4 is expected to be less than I, and it is. Next one. What is the value at time 2 of 1,000 to be paid 5 years from now if the market pays nominal interest rate I12 equals 6% convertible monthly? Do you want to try? Let's do it together. What is the value at time 2 of 1,000 to be paid 5 years from now if the market pays I12 is equal to 0.06. Convertible monthly, right? This tells me that it's monthly because of the number 12 there, 12 times a year. So I-12 over 12 equals 0.005. What is my A of t function? Compound interest, right? A of t is 1 plus I-12 over 12 to the 12 times t, because this little monthly rate should be compounded the number of years times 12, because it's happening 12 times per year, right? Okay, so what do you think we should do here? Do we need to bring it back to 0 and then forward to 2, or no? The answer is no, you don't need to, because this is compounding of interest. That only is for other functions, right? Such as simple interest. Here I can just go directly. How many months between time 2 years and time, let me label this properly, t equals 2 years, and here t equals 5 years. So how many months between here and here? 36 months, right? 36 months. And I just have to discount 36 months. So this is 1,000. The interest rate is 0.005. So 1.005 raised to the minus 36. I'm discounting. So my V of t is 1 over A of t, where A of t is 1 plus the monthly rate to the 12 times t. So V of t, the discount function, is equal to 1 plus I-12 over 12 to the negative 12 times t. So my t is 3 years. I'm timesing by 12. That's how I got this minus 36. Are you with me? And even if you did it the long way, what would you have done? Wouldn't you have gone like this? 0, 2, 5. You would have to do V of 5 and then A of 2, right? So that would have given you 1,000 divided by 1.005 to the 60th power, because there are 60 months in 5 years, and then you go forward 24. 1.005 to the 24. So of course you get the same answer, 1,000 divided by 1.005 to the 36th power, after these cancel. Same answer. What is the answer? Let us see. 1.005 raised to the minus 36 times 1,000. 835.65. Does this make sense? What's your question, folks? Yeah.
Professor, can we convert the nominal rate to the regular rate and then we
You
do
could.
the calculation?
You could. Sure. You could convert it to I and then use years. No problem.
Why don't we start at 5 years and then go back rather than go from 2 years and then back to 5?
You want to start at 2 years?
I mean that's what I.
The question is saying that $1,000 exists at t equals 5 years. What is its value at t equals 2 years? So isn't that just as simple as discounting 3 years?
Oh, okay.
Except that my rate is given in terms of monthly. So I just have to convert the 3 years to how many months? 36 months. Finished. Tell me again what you wanted to do.
I was just confused. I was confused by the wording because it first said times 2. So I mistakenly thought to start from there instead of 5 years, especially because it said to be paid 5 years from now.
Right, so it's saying, what is the value at time 2? It's a question mark. Of 1,000 to be paid 5 years from now, if the market pays this interest rate monthly.
Oh,
Okay? Okay. If there are no questions, let's talk about discount. The nominal discount rate this time compounded M times a year. Just like you have IM, you have DM. So let's draw a timeline. Starting at time 0, I have, let's say it's monthly, okay? Just so you can picture it. I have month 1 and month 2, and all the way here I have month 12. So that would just be year 1, M over M, which is 1. And let's say that it's convertible monthly, just so you can picture it. So this would be 1 over 12, 2 over 12, 12 over 12, which is 1. What is A of t in terms of D? What is the accumulation function A of t in terms of D, not in terms of I? I know that in terms of I, A of t is 1 plus I to the t, right? Which is equal to 1 plus Im over m to the m times t, right? But I'm asking you, as in a simple case, what is the discount function? What is the accumulation function in terms of D? And in turn, once I get the accumulation function, I can also get the discount function because they are reciprocals. So before anything else, tell me what is A of t in terms of D? Yeah.
Can we just substitute D in terms of D?
D into which?
In terms of E? I mean,
I?
yeah.
Yes, certainly. So since we know that 1 plus I equals 1 minus D to the minus 1 power, right? We start with this equation. 1 plus I, 1 minus D equals 1. That we know, right? So 1 plus I equals 1 over 1 minus D. So if I were to start here, I would see that the A of t function is equal to 1 over 1 minus D. But we want to talk about dm over m, the monthly discount. So in going from here to here, I would be timesing by 1 over 1 minus dm over m. And in going from here to here, I would be timesing by 1 over 1 minus dm over m, and so forth, because this is happening monthly. So couldn't I say 1 minus d to the minus 1 equals 1 minus dm over m to the minus m? Because I have 1 minus dm over m to the minus 1, to the minus 2, to the minus 3. So the value here would be, let's say this is k. This value here would be k, 1 over 1 minus dm over m to the second power. Follow what I'm saying? And here the value would be k, 1 over 1 minus dm over m to the mth power. Where the accumulation function for the monthly is just 1 over 1 minus dm over m. Does this make sense to you or no? So I want to somewhere say that dm over m is equal to d1 over m. And this is equal to the effective discount rate per 1/n of a year. Any question? All I did was use the fact that 1 plus I is 1 over 1 minus D. And since I know the formula for IM over M, I can just switch it to 1 over 1 minus dm over m. That's it. Somewhere here I should, yeah, this is good. Next page. So let me draw that timeline again so we have it. 0, 1, sorry, thanks so much. 0, 1, in going from here to here, 1 plus IM over m to the mth power. So if I start with k, that's my A function right here, accumulation function. So if I start with k, I end up with k 1 plus IM over m to the mth power. If I discount the amount at t equals 1 back to t equals 0, I would be multiplying. Discount factor would be multiplied by 1 minus dm over m to the mth power. Discounting. I'm going backwards. That's why this doesn't have a minus exponent. Okay? I'm going forward and then discounting back. So here I would get k 1 plus IM over m to the mth power times 1 minus dm over m to the mth power. Again, we set these two equal, just like we did for the I function, IM over m function, same thing. Set these equal, so you get 1 plus IM over m to the m equals 1 minus dm over m to the minus m. Set these two equal, the k's will cancel, and you would get this equals 1. Let me write it. 1 plus IM over m to the m times 1 minus dm over m to the m equals 1. The k's have canceled. This k has canceled with this k, and therefore 1 is equal to this product. So when I bring this to the right-hand side, it now has a minus exponent. So this is where the k's have canceled like that. Let's do some problems. A bank offers nominal discount rate 4.8% compounded monthly. That means D12, right? D12 is equal to 0.048. Find the annual effective interest rate and the annual effective discount rate. So they're saying find I and find D. Find I, annual, and find D, annual. So on the bottom of the page, let us write the main formula that will help you with all of these kinds of problems. 1 plus I equals 1 plus IM over M to the M equals 1 over 1 minus D equals 1 over 1 minus dn over n to the n. So m and n don't necessarily have to be the same all the time. Perhaps you want a discount rate convertible quarterly, and perhaps I is a nominal interest rate convertible monthly. That's why these are different. So it might say you have a nominal interest rate convertible monthly, convert it to a nominal discount rate convertible quarterly. That's why these are different. Follow you? Follow? Are you with me? Okay. So back to our problem. D12 equals 0.048. Please find I and D. What do you say? I want I, so let's start there. 1 plus I equals 1 minus D12 over 12 to the minus 12 power. And solve. So I equals 1 minus 0.004 raised to the minus 12 minus 1. 1 minus 0.004, raise it to the negative 12 power, minus 1. 0.04927. 0.049, let's call it 3. I equals 0.0493. And we also want D. So how about 1 minus D equals 1 minus D12 over 12 to the 12. See, look, stare at this for 1 second. Look at these two. I'm setting the 1 minus D equal to this one. And I'm dropping both the minus 1 exponents because I don't need them. I could write both of them to the minus 1 power or both of them to the plus 1 power. Follow me? That's one way to do it. The other way to do it would have been to convert this I to D by saying D equals I over 1 plus I. Nothing wrong with that either. Follow me? So anyway, let me finish up this way. So 1 minus D equals 1 minus D12 over 12 to the 12. So minus D equals 1 minus 0.004 to the 12 minus 1. So 1 minus 0.004 raised to the 12 minus 1. 0.0469. D equals 0.04695, so 0470. Let's try the next one. Find the effective annual discount rate for a nominal interest rate. Let's add the word Oh, you have it here, I don't in my notes. Find the effective annual discount rate for a nominal interest rate of 8% convertible quarterly. So I4 is equal to 0.08. So I4 over 4 equals 0.02. And what do they want? The effective annual discount rate, D. So what's your formula? 1 plus I4 over 4 to the 4th power equals 1 minus D to the minus 1 power. And solve. 1 plus 0.02 to the minus 4 equals 1 minus D. Bring the 1 to the other side. So you have 1.02 raised to the minus 4 minus 1 minus 0.07615 minus 0.07615 equals D minus D. So D equals 0.0762. Get it? Can I ask you to go through these at home? And I will post this whole page. I will scan this whole page so that you can compare your answers. And next time, I want to begin with lecture 1B, which has already been posted. So if you could bring those notes with you. Now, when is your homework due?